we're talking about all types of factoring, and we want to use special product patterns to factor polynomials. So we have two steps up here that we want to pay attention to. First step is look for common factors that will make your life easier. And the second one is count the terms in the polynomial. So here we're talking about binomials specifically, so there's two terms. So we should be thinking difference of squares, sum of cubes, or difference of cubes. So if we look at this first term here, we have a binomial, and that's x squared. And hopefully we understand that 25, that's 5 squared. So these are two squared terms here, and we can write down the square root of x squared and the square root of 25. So if we're doing difference of squares, I know, well, let's do that. The square root of x squared is x, and the square root of 25 is 5. So I know that I'm going to have two binomials, and I know that they're going to be conjugate pairs. So we have a minus and a plus. Now the first term, take the square root of it as x, that goes in for the first term of each binomial. And then the square root of 25 is 5, that goes in for the second term of each binomial. And now we have factored x squared minus 25. Next one that we look at is we have x squared here, and we have a 4, and we have an 81. So hopefully we recognize that 2 times 2 is 4, x times x is x squared, and 9 times 9 is 81. So we can take the square root of 4x squared, and that is going to be equal to 2x. And then we can take the square root of 81, and that's equal to 9. So now we still have our conjugate pair. So it's going to be, could be plus minus or minus plus, doesn't matter. Then we take our first term square root, and we get 2x, so that goes 2x and 2x. And then our second term square root, that gives our second terms. So 9 and 9. Now we look at example 3, and we notice that we don't have a perfect square. Here we have 2x to the 4th and 128. Well, I know that 2 is not a perfect square, so the first thing that we want to do is we want to see if we can make this perfect square. So they're both even though, 2 and 128 are even, so I can divide these both by 2. And what we get is 2 divided by 2, or 2x to the 4th divided by 2 is just x to the 4th. And negative 128 divided by 2 is negative 64. And we got to have the 2 out front of our parenthesis. Now, hopefully we recognize that the square root of x to the 4th is x squared, and the square root of 64 is 8. So now, hopefully we can come up with our binomial conjugate pair for minus 64. We still have to have the 2 out front of the parentheses because we did factor that one out already. Then we have our minus and plus. Then we took the square root of x to the 4th as x squared. So that goes for the first term of both binomials, and the square root of 64 is 8. So that goes for the second term of both binomials. Now we look down, and we still have binomials, but we should notice that we have x to the 3rd. So now, instead of thinking of squares and thinking difference of squares, we should be thinking cubes, and in this case, difference of cubes. So I want to take x cubed, and I'm taking the cube root, and 8, and I'm taking the cube root. And the cube root of x cubed is just x, and the cube root of 8 is 2. So I know difference means that the first sign is going to match the original binomial. So we have minus. And I know that I'm going to have 2 addition signs. So I already have 1 addition sign. So I know that I'm going to have another addition sign and another addition sign. And here, the first term is x, and the second term is 2. Now we have x squared goes here. So we take the first term and we square it. So that is x squared goes right there. So that's just x squared. Then the last term, we take the last term squared. So that's going to be 2 squared. So that becomes 4. And then the middle term is just these 2 terms multiplied together. So 2x, and we multiply those together, and we just get that 2x. So there is the difference of square, or difference of cubes factored. I kind of ran over a little bit on the space for number 5. So again, the cube root of x cubed is equal to just x. And the cube root of 64 is 4. So once we have that, we can start filling out our formula. We should have a leading binomial and then a trinomial. The first sign matches. The last sign is always addition, and we always have 1 subtraction sign. So now we can put in our numbers. So the first one is just x and 4. Then we have the x squared, which is just x squared. Then we have the 4 squared, which is 16. And then we have 4 times x, which is just 4 times x. And then the last one here, there's no common terms, because here we have an odd 27, where we only have 3 and 9 go into 27. So 3 and 9 do not go into 8, so we can't factor anything out. So now we just have to stick with just doing the cube root. So we take the cube root of 8x cubed, which becomes 2x. And then we have the cube root of 27, which is equal to 3. So once we have those, we got to remember our pattern. Remember, the first sign matches the sign of the binomial, and our last sign is always addition, and we always have 1 subtraction sign. So we take the first term, cube root, and we get 2. And we take the second cube root, and we get 3. Then we have our first term squared. So we have 2x squared, and the squared has to get distributed to all of those terms. So 2 times 2 is 4x squared. And then we have the last term squared. So 3 squared becomes 9. And then for our middle term, we take the first term, which is 2x, and we multiply it by the last, which is 3. So we get 2x times 3, which becomes 6x.